In an unprecedented effort to unravel the intricate genetic tapestry of Puerto Rico, scientists embarked on a groundbreaking study. This monumental task required the collaboration of experts from various fields, including genetics, anthropology, and history, to ensure a comprehensive understanding of the data. This ambitious project involved analyzing the DNA of 63,000 individuals, making it one of the largest genetic studies ever conducted on a single population. The sheer scale of the study provided a unique opportunity to explore the genetic diversity and complexity of the Puerto Rican people in unprecedented detail. Let's break it down by the numbers. The data reveals that Puerto Ricans aged 60 and over have an average of 36% total indigenous DNA, with 20.5% coming from indigenous Puerto Rican ancestors and 15.5% from Central and South American indigenous populations. For those aged 50 to 59, total indigenous DNA rises to 38.6%, with the same percentage of Puerto Rican ancestry, but an increase in Central and South American ancestry to 18.1%.
Moving to ages 40 to 49, the total indigenous percentage jumps to 45%, with 24.87% from Central and South America. In ages 30 to 39, 43.4% of the DNA is indigenous, with 23.8% from Central and South America. But the most striking increase appears in the youngest group, aged 18 to 29. Here, the total indigenous percentage skyrockets to 65%, with nearly half, 46%, coming from Central and South American ancestry. Scientist: this trend of increasing Central and South American indigenous DNA in younger generations is likely the result of migration and intermarriage over centuries. Puerto Rico has long migrated to North America, where they have mixed with Central and South Americans, and over time, their genetic influence has become more prominent, particularly in recent generations. Moving to ages 40 to 49, the total indigenous percentage jumps to 45%, with 24.87% from Central and South America. In ages 30 to 39, 43.4% of the DNA is indigenous, with 23.8% from Central and South America. But the most striking increase appears in the youngest group, aged 18 to 29. Here, the total indigenous percentage skyrockets to 65%, with nearly half, 46%, coming from Central and South American ancestry.
One of the most striking findings of the study was the presence of indigenous DNA in all individuals tested. This revelation was not just a scientific breakthrough, but also a profound connection to the island's ancient roots. The meticulous process of DNA analysis revealed a hidden chapter of history, one that has been silently carried within the genes of Puerto Ricans for centuries. So why do we see this increase in Central and South American DNA in younger generations? It turns out migration and gene flow have played a major role. Puerto Ricans have migrated to mainland USA mostly since the 1930s, many intermarrying with Central and South Americans over centuries, but this alone cannot account for 70% of the population having Central and South American DNA. What's fascinating is that even if these migrations happened centuries ago, the genetic expression of Central and South American indigenous ancestry has become more pronounced in the newer generations. As time has passed, the genes from these early migrants have become an integral part of Puerto Rico's genetic identity. This rise in Central and South American DNA could also be linked to a darker part of history, the indigenous slave trade of the late 1500s and 1600s. Historical records suggest that when the local Taino population resisted Spanish efforts to enslave them, colonizers brought enslaved indigenous people from Central and South America to Puerto Rico. Although exact numbers are unknown, this data suggests that thousands of indigenous people from regions like modern-day Mexico, Colombia, and Venezuela were brought to the island, contributing to the genetic landscape we see today. Charles Darwin's theory of evolution, particularly the concepts of natural selection, gene flow, and adaptation, could offer insights into why Central and South American DNA is becoming more prevalent in the Puerto Rican population. Darwin's work, though primarily focused on species adaptation, can be applied to human populations in terms of genetic inheritance and the evolution of traits over generations. Here's how Darwin's theory can help explain the increasing percentage of Central and South American DNA in Puerto Ricans. 1. Gene flow and migration. One of the key mechanisms in Darwin's theory is gene flow, the transfer of genetic material between populations. Puerto Rico has a long history of migration, including the movement of people from Central and South America. Over centuries, this gene flow has introduced new genetic variations into the Puerto Rican gene pool. According to Darwin's principles, as these populations intermixed, their genetic traits were passed down through generations. As a result, the DNA from Central and South American indigenous populations became more common in Puerto Rico's population. Younger generations would naturally inherit more of this genetic material through intermarriage and reproduction over time. As the Central and South American populations integrated more into Puerto Rican society, the frequency of their genes increased.
The study found that the proportion of indigenous DNA varies across different individuals and regions within Puerto Rico. This variation is a reflection of the island's diverse history and the different waves of migration and settlement that have occurred over the centuries. Each region tells a unique story of how the Taino heritage has been preserved and integrated into the local culture. Natural selection and adaptation. Darwin's idea of natural selection can also play a role in explaining the rise of Central and South American DNA in Puerto Ricans. While there may not be direct environmental pressures that favor Central and South American genes, certain traits or genetic advantages could have made descendants of these groups more successful in survival and reproduction. Cultural adaptation and the integration of these groups into Puerto Rican society over the centuries may have resulted in some selective pressures that allowed their genes to persist. For example, if individuals with Central and South American DNA had higher reproductive success or more offspring, their genetic material would naturally become more prevalent in future generations. 1. Genetic drift and population bottlenecks. Darwin's theory also acknowledges the role of genetic drift, random changes in the frequency of alleles, gene variants, in a population. Historically, when populations are reduced due to events like disease, colonial conflicts, or the effects of enslavement, this can lead to a bottleneck, where only certain genes survive and are passed on. During Puerto Rico's colonial period, the original Taino population was decimated by disease and forced labor. Meanwhile, indigenous people from Central and South America were brought to the island as enslaved laborers, which increased the prevalence of their DNA in the local gene pool. Central and South American genes could have survived and become more widespread simply due to this bottleneck effect, where only a subset of the population contributed to the future gene pool. 1. Cumulative effects. Over time, Darwin's theory stresses the gradual nature of evolutionary change. The increased percentage of Central and South American DNA in younger Puerto Ricans could be the result of accumulated gene flow over centuries. While the original indigenous population of Puerto Rico may have had more Taino ancestry, continued migration from Central and South America has over generations increased the presence of DNA from those regions. The cumulative effect of these migrations and genetic intermixing may now be more visible in the DNA of younger generations. Darwin's principle of gradualism, the idea that small, incremental changes over time can lead to significant shifts in populations, applies here. The Central and South American DNA didn't suddenly appear. It has been slowly increasing over time due to consistent gene flow and integration. 1. Evolution of a genetic mosaic. Darwin's theory also highlights the diversity of life as a product of both adaptation and the mixing of different populations. In Puerto Rico's case, the population is a genetic mosaic representing European, African, indigenous Taino, and Central and South American indigenous DNA. As migration continued through the centuries, this mosaic shifted, and now Central and South American DNA is becoming more prominent. This shift could be explained as part of the ongoing evolution of the Puerto Rican population. As people from Central and South America moved to Puerto Rico, the next generations carried their genetic markers, and those markers became a larger portion of the gene pool. This is reflective of the evolutionary process that Darwin described, where populations adapt and change over time based on external influences such as migration, environment, and social dynamics. Conclusion. In summary, Darwin's theory of evolution can help explain why Central and South American DNA has become more prevalent in Puerto Rico. Through gene flow via migration, natural selection, genetic drift, and the cumulative effects of generations of intermarriage, the population has evolved to reflect the genetic influences of indigenous people from both Puerto Rico and Central and South America. This gradual change is an example of how human populations are constantly evolving, adapting, and integrating new genetic traits over time, in line with Darwin's principles. Colonialism left us with a profound legacy, one that goes beyond borders. It taught us how to discriminate against ourselves. We know today that race is nothing more than a social construct, an idea designed to categorize and divide. But the Spanish caste system, the castas system, instilled a belief that we must identify ourselves based on a mix of ethnicities, a system that, in subtle ways, is still practiced today. The reality is that the only true identity we possess as a people is shaped by our culture and our adaptation to the land where we live. As our study reveals, the genes that have evolved and adapted to our geographical region are making themselves known again. Our roots are not just in Spain, Portugal, or Africa, they are here, in the Americas. When you take a DNA test, it doesn't solely trace your ancestry to Europe or Africa. Instead, it identifies your connection to your indigenous roots, to the Americas themselves. This is who we are. I strongly believe that Hispanics or Latinos should begin identifying not by outdated labels of the past, but as Indo-Americans, descendants of the land, with a rich and complex heritage that goes back thousands of years. Our future lies in embracing who we are, people of the Americas, shaped by this land and united in our cultural legacy. We are and always will be Indo-Americans. This applies to every Latin American country.